All right, we are now going to talk about our other important measure of spread. This measure of spread, or these measures of spread, I should say, only go with the mean when you use the mean for measure of center. So again, if your data is skewed, you should use the median. And if you use the median, you should be talking about range and IQR for spread. Those go together. At no point in time, if I'm talking about the mean as my measure of center, should I be using the IQR to talk about spread? They do not go together. They're very separate and they should be kept separate. So when you use the mean for measures of center, which again is when your data looks rather symmetrical, unimodal, kind of normal, that bell-shaped curve, you are going to use measures of spread called the variance and the standard deviation. These are two things that go together with each other, and they are linked explicitly to the mean. The variance, in fact, is and again, I'm going to shift this a little bit so you can kind of see it. All right, so this variable in here is the Greek letter sigma, and sigma squared is the variance, and it does measure the spread of the data around the mean. So when I show you a formula in a minute, the average is actually part of the calculation of this. That's why they go together. And the standard deviation, which is, you notice, just visibly different. The only difference is this has a square, this does not. And that's because the standard deviation is the square root of the variance. Therefore, the variance and standard deviation do indeed measure the spread. One is squaring, the other is not, and they are the spread around the actual average. So that's why they go with the mean. So this is the formula for the variance. Notice that sigma squared. This little f is in here. If you had a frequency table, this would be the formula that you would use for the sigma squared, for variance. If you did not have a table, a frequency table, and you just had data values, then this wouldn't be there. I'll get rid of that. And so really what you're doing is you're finding the difference between every piece of observed data and the mean. You're squaring that difference and then you're adding all of those up. That's all that means, add them all up. And then you're kind of averaging that value by dividing by n. N is the number of terms in your data set. So one of the reasons this is being squared is some of your data will be below the mean and some of your data will be above the mean. That's how it works. And if that means these differences, half would be negative and about half would be positive. And if you add up negatives and positives, they have a tendency to cancel each other out. So by squaring it, I will make every single difference positive. And that's why at the end, when we talk about standard deviation, we come back and take the square root. So we're taking that squared out of it, but we're also making sure we're counting the values that are all positive differences from that mean. So this, again, if I had a frequency table, that's what that little f is. If you don't have a frequency table, your formula would be looking like this. So it's a pretty horrendous calculation, I'm not going to lie. I'm pretty sure these formulas are given to you. This would be how you would do it by hand. And again, I'll kind of shift this screen a little bit for you so you can kind of see. There's the formula I just showed you for variance up here without the little frequency f. And again, it's the difference between every observed value from the mean squared. Add those all up and divide by how many data values you have. So if you have to do this by hand, a very cruel little trick to make you do. If these are your data values, and this is the actual mean of all of these data values, so the mean again is you add these all up and divide by however many there are, and then you would take the difference between each value and the mean. That's what's happening here. So see how some are negative and some are positive? And then I would have to square those. So I would square each of these values. And so then they all become positive values. And then down here, I add those all up to get 10.84, but I have to divide that by how many pieces of data I have. So I'm dividing by 6. So the variance is 1.81. And then if I wanted to find the standard deviation of this, I would simply take the square root of 1.81. And that would give me my standard deviation. So on a standard deviation, the standard deviation, not the variance. This formula is just used to get to here. But the standard deviation is the one that makes more sense in terms of what's going on. So on this set of data, I would say on average, my data values are about whatever this equals away from the mean of 2.83. And it's always the same units as the mean for standard deviation. And the nice thing about this, now that I've shown you all of this fantastic technique to solve it by hand, is voila, good news. You're only ever going to let the calculator do this. We are not going to calculate standard deviation and variance by hand. It is messy and clunky and very easy to make small mistakes. So we will not be doing it. We'll let our calculator do it for us. That's the good news. But you do need to know the difference between the standard deviation and the variance is that squaring. If I have the standard deviation, I would square it to get variance. And if I give you variance, you would have to square root it to get standard deviation. And the IB exam will flip-flop back and forth, and sometimes they'll give you variance and you need standard deviation. So you have to make that one little quick calculation. So this, again, is the same data that you had earlier. It is from your shoe sizes. So we're going to pull up our calculator, and you already know how to do this. I've already shown you this. If you want to calculate one variable stats, if you hit stat, go over to calculate. My data's already in there, so I don't need to re-put it in there, and do one variable stats. And again, my data is in list 1, so I have to change that to list 1, and this is not a frequency table. It is just a string of single individual data values, so I put nothing here. And then I go down to calculate, and I hit enter, and this is the average shoe size for your class was 9.3. These are things that are used to calculate the standard deviation. Notice that these two different things down here that are pretty close. This is the sigma we're looking for. This is your standard deviation, 2.17. This is also a standard deviation, but this is for a sample, and this is assuming it's a population. And just so you know, the only difference is dividing by n versus dividing by n minus 1. My understanding on IB is if they give you a set of data, the assumption is it is a population of values, so you would always be using this sigma value. So my standard deviation is 2.17, and if I wanted the variance, I would have to square 2.17 to get the variance. I also want to point out that the 5-number summary that we already calculated by hand is all right here, so you actually don't ever need to do that by hand either. It's a little bit easier than standard deviation, but it's all right here. So you can get the 5-number summary from the same place you get the mean and the standard deviation. So again, notice that these go together in terms of center and spread. And then when I scroll down, I can get my center and I can quickly find my IQR by subtracting, or my range by subtracting. So that's how you kind of do it with your calculator. That's how you find it. There's no, I don't want you using that crazy formula. So again, here's the output that I just showed you. The difference is I didn't calculate the variance for this, so I would literally have to square 2.17 to get that variance value. So that is it for the information. Again, if you're talking about your center being your mean, you want to use the standard deviation to talk about the spread or the dispersion. And if you have a median, you want to use the IQR to talk about your dispersion or your spread. So you're going to try this from one of the IB classes that we collected data on. These are the number of states that were visited by a particular class. And again, I'm not putting like 2, 3, or 4 of these classes together, because that would be a lot of data and you would have to put it all in your calculator. So we're sticking to a single group. So this is around 20 or so, 21 pieces of data. I don't remember how many exactly. But I want you to do all of these things. So you're going to have to pause this thing and you're going to have to do all of these. And it's going to take a bit because I need you to find the median, the range, the IQR, and if there are any outliers. Then I want you to make a box plot. Then I want you to find the mean and standard deviation and the variance of this data set. And then based on what you saw in your box plot, you're going to decide which of these you should use to describe the distribution. Should you use the median and the IQR, or should you use the mean and the standard deviation, which is a continuation of what we talked about last class. So pause this thing, put this data in your calculator, and then take a look at these. We'll take a look at these one at a time. So this may take you a few minutes, but that's all right. Get her done. Do it all in your calculator though, except for this last decision. You don't need to make your box plot by hand. You can, but you don't have to. I want you to practice using your calculator. Pause. All right, so here goes the answers. So for the first answer, if you do one variable stats, you will get, this is the bottom half of it. Sorry, half of it we have to scroll down. The range is the max minus the min, and clearly I have a typo in here because that should have been the number 5, not the number 4. So look at how fast I can fix that. So 40 is my max and 5 is my min. So the range of states visited for you guys was 35 states. The IQR is the difference between the quartiles. So for us, that means I'm looking at 11 and 18. And if I subtract those, I would get 7 states. So the IQR is 7 states. So half of you had a span of data values of only 7 states in number of states you visited. So now to determine if there's an outlier, I have to take this IQR of 7 and multiply by 1.5. So this is just step number 1. So this 10.5 doesn't give me any information about do I have an outlier or not until I apply it to this 11 and this 18. So this 10.5 has to be applied to both of these quartiles to kind of build your fences out. So if I look down here, 7 states is right around here. 11 states is my first quartile, and 18 is over here. So those are my quartiles. So what I'm saying is this is the middle 50% of my data. I'm willing to come out a little ways before I consider something an outlier in both directions, and this is how far I'm willing to go out. So if I add 10.5 to 18, I'm not willing to go past 28.5 states. So you'll notice that I would build what I call a fence right here after 28, and anything beyond this would be an outlier. So guess what? That is outside of that fence. That is an outlier. Whoever went to 40 states is an extreme observation and outside of the general pattern of the rest of the class. I also have to subtract it from the first quartile. So notice I'm going to the left. That's why I'm subtracting. So if I subtract 10.5 from 11, I get a half. There is nothing below a half over here. It would be basically if someone had gone to no states, they would be an outlier, and it'd also be weird because you live in a state, so that's impossible. So there are no outliers on the bottom half, but this 40 is an outlier. Now I made a box plot out of this, and I made what is called a modified box plot. So if you remember when you were at your box, your graphing screen, and there were 2 box plots in a row, one of them is like a box boop, with a little asterisk, and the other one is just a box without an asterisk. So a modified box plot is the first one with this little asterisk on it. And what it's going to do is it will calculate outliers for you. The second one we did that we did for the first set of data doesn't calculate any outliers. It literally goes min to max, and there you go. But this one will calculate an outlier. So notice how this little dot is out here by itself. That's the kid who went to 40 states. That's an outlier. And then your whisker comes back to the next biggest data value. So this data value I went through trace. So you can see that the next value below the outlier is 28. So my whisker ends at the 28, which is the next value below the outlier. So if you want to do a modified box plot, which is the first one that has the little asterisk on it, it will give you whether you have outliers by the 1.5 times IQR rule. So if you're using technology on the IB exam and ask for that, you can use your calculator. We'll give it to you. If you're on the portion that doesn't allow a calculator, you're going to have to know how to calculate the 1.5 times IQR rule. All right, so that's the box plot. Now we're going to move on to the mean and standard deviation. Again, this is one variable stats. So the average states visited was about 14.9 states with a standard deviation of 7.5. Again, I don't use this one. When you take AP Stats, if you take AP Stats, you'll be using this one I'm scribbling out a bit more. But for us, we're going to use the 7.5. That's so on average, you guys visited about 14.9 or 15 states, and each of you about 7.5 states away from that. So down to about 7 and up to about 21. So that really kind of captures similar to what our interquartile range was capturing. And the variance, I literally have to square 7.5, and I did that in my calculator, and I got 56.25. And to finish this off, I look at this thing. There is definitely an outlier here. So that means this is skewed heavily skewed to the right. And so because it's heavily skewed, I would choose to use the median and the IQR or the range to talk about center and spread, because this 40 is pulling your mean. Your median is 12. Remember, the mean was almost 15, so it's pulling that value towards that kid who went to 40 states. So that kid went to 40 states is really pulling heavy on this set of data. And that is it. Enjoy